Hi guys, welcome to section 5.6, which we are going to be finding the inverses of functions. So we're going to spend a lot of time in class during block day finding inverses, but I just wanted to give you an introduction to what an inverse is. So we are going to explore understanding inverses of functions. First, we should know how to determine whether a relation is a function. So you guys have done this before. In math, a relation is any pairing of elements from one set, the input, the domain values, to another, the output or the range values. Okay, so remember, usually when we talk about input and domain, we're talking about x values. And when we talk about output and range values, that's your y values. Okay, a function is a relation in which each input is paired with exactly one output. Okay, so basically a relation, there's really no rules how many outputs an input can be mapped to. However, in a function, you can only map every x value to one y value. So we are going to look at these three different representations of a relation and determine whether it is a function. If it is not, we're going to tell why. So, number one, we have this set of points 2, 4, 3, 1, 3, negative 1, 4, 1, and 9, negative 4. So we need to make sure that every x value is only paired with one y value, which means the x values cannot be repeated. So I have the x value of 2, I have the x value of 3, 4, and 9. Those are all going to their own y values, so this is a function. In number 2, we have a mapping diagram. My domain or my input values, I have negative 35, negative 5, and 0, and the arrows show what output value they are going to. So negative 35 is going to 1 and 22. Negative 5 is going to 4, and 0 is going to 1. So this actually is not a function because of negative 35. This is not a function because negative 35 has two outputs. Okay, so that is illegal. So that one's not a function. In number 3, we have a graph. Now, I'm not sure if you guys remember the vertical line test, but graphically, we can use the vertical line test to determine whether a relation is a function. Because if we draw vertical lines down the graph, and if we hit more than one point at a time, that means that this x value is going to more than one y value. So for instance, if we look at this line that I've drawn at the x value of 2, 2 is going to this point and to this point. And everywhere I draw a line, I'm basically touching two different points. So this circle is not a function because it does not pass the vertical line test. So, no. And I'm just going to write the VLT, vertical line test. Okay, so once we figure out a relation is a function, we need to determine whether it's a one-to-one function or a many-to-one function. Okay, a one-to-one function is a function in which no output is used more than once. And a many-to-one function is a function in which at least one output is used more than once. Okay, so before we read about an inverse relation, if we look down here at these mapping diagrams, we can see that in letter A, in this one right here, every x value is going to exactly one y value. None of these y values are being repeated. However, in B, do you see that both 1 and 4 are going to the y value of 2? That means that this is many to one because many x values are going to the same y value. So that's totally okay. You just can't have this one x value going to two y values. And so this one over here is 1 to 1. The other part of this mapping diagram is the inverse of the function. So I'm going to come back up here. An inverse relation reverses the pairings of a relation. So, put simply, it switches the input, the domain values, and the output, the range values. So basically, we're just swapping them. So if we look at letter A, negative 4, negative 2, switch to negative 2, negative 4. 0, negative 3 is going to switch to negative 3, 0. 1, 2 is going to switch to 2, 1. And 4, 1 switches to 1, 4. Now, in our instructions, it says, from each mapping diagram, determine whether the function is one-to-one or many-to-one. So we did that. In letter A, it's one-to-one. Then it says, tell whether the inverse is also a function. And this one, because every x value is going to one y value, this is a function. If we look at letter B, this was our many-to-one function. And when we reverse the inputs and outputs, negative 4, negative 2 goes to negative 2, negative 4. 0, negative 3 becomes negative 3, 0. 1 goes to 2, so that means 2 goes to 1. And 4 goes to 2, so that means 2 goes to 4. And what we have going on right here, where 2 is going to 2 output values, makes this not a function. So what I hope you see is that this one-to-one function in letter A, the inverse was a function. The many-to-one function in letter B, its inverse was not a function. So it has a question, based on your conclusions above, what must be true about a function for its inverse to also be a function? It must be 1, 2, 1. So every input has exactly one output. And no outputs are used more than once. Okay, so we're just going to look at these ordered pairs, and we are going to find the inverse and talk about it. Given the function written as a set of ordered pairs, write its inverse as a set of ordered pairs. Then graph the inverse points along with the original points. So remember, to find the inverse, we just reverse the ordered pairs. So this function with negative 4, negative 2 is going to switch to negative 2, negative 4. 0, negative 3 changes to negative 3, 0. 1, 2 changes to 2, 1. 4, 1 changes to 1, 4. Okay, so we're going to plot these points. Negative 2, negative 4. Negative 3, 0. 2, 1. And 1, 4. So the points that were plotted to begin with were the points of the function, and then the points I plotted are in blue. If you don't have colors, maybe put X's or something so you can tell the difference. Do you notice a relationship between the graph of the original points and the graph of its inverse in relation to this line that's drawn on here, y equals x, which I'm going to highlight in red? So we have this line y equals x, which is the line, which I don't know why that's so squiggly, sorry, with a slope of 1 and a y-intercept of 0. Do you notice that these points that we have reversed, they're equidistant on either side of that line? So basically, they've been flipped over that line, or reflected, right? So this is true about every inverse function and the original function. They are, so it says, what do you notice about the graphs of a function and its inverse in relation to the line y equals x? They are reflections of each other over the line y equals x. Okay, so before I let you go, we will talk about this more in class, but I just want to recap what we talked about. I wanted to remind you what a function was. A function was a relation where every x value just goes to one y value. So number 2 here was not a function because negative 35 was going to 2 y values, and then number 3 wasn't either, using our vertical line test. Once we determine something is a function, we need to determine whether its inverse is also a function, and that's where we use one-to-one and many-to-one. What we figured out, letter A was a one-to-one function because every output value in the range was only used once, and that resulted in its inverse being a function. But letter B was a many-to-one function because of these two inputs going to the same output, which then resulted in the inverse not being a function. So in order for a function to have an inverse that's also a function, it must be one-to-one. And so far we know that to find an inverse, we just reverse the ordered pairs, and what that does is reflect them across the line y equals x. And we will be talking a lot more about this in class tomorrow. See you then.